So in this video, I want to take a look at using FileZilla and Notepad++ to do remote editing of files on my PiDP11. So I've got my PiDP11 set up and running. I'm actually running the BSD 2.11 version. It's my favorite, I think, version of Unix on the machine. I'm logged into the machine as my STB user. So I had created a user previously and set up. I've got a octal dump utility I'm working on here, and we'll make edits to that and see if we can finish it in this video. There's a makefile here to control the project. And we'll look at how this all ties together. So I've downloaded FileZilla, installed it on my machine. I've downloaded Notepad++ installed on my machine. And Notepad++ is a great text editor. It does color highlighting, it supports macros. There's just all kinds of features programmers can really use in a text editor. These are downloaded and installed on my machine. I've been using both these utilities for years in both my personal and professional life. They're just great Windows-based programs. This is the FileZilla client. I have created some various, I'll actually take a look at one of these, some client definitions. So I have a site manager entry here for STB, or the 211 BSD STB login. When I set up 211 BSD on my PiDP11, I set up networking on it, and I gave it the address on my local network of 10.0.0.200. So that's the address we've got here, and it's going to log in as STB and the password I'm using for that account. So this is already connected. In the STB folder on the machine, I've drilled down into this OD folder. OD has my octal dump utility sitting here and the makefile for it. I am looking at the temp folder here that FileZilla uses as part of the editing process. So let's just go ahead and edit one of these and take a look at it. Let's look at the makefile first. Actually, there's one other thing we need to hit here first for this to actually work. So in settings, if we go to file type associations, notice that I have anything with a C file type associated to Notepad++. I have other development tools on my Windows machine, such as the Micro-C Pro for PIC32. Got a number of different development environments on here. And in this case, when I tell FileZilla to edit a file with a C extension, I want it to run Notepad++, even though the file extension associations on my machine are different. Those will override those default associations. So for C files, for header files, and things without an extension, it'll go ahead and run Notepad++. And between the quotes here is the fully qualified path to where Notepad++ is installed. So if I go ahead and right-click on Makefile and do View Edit, a couple of things here will happen. It will FTP it down onto my PC. You'll see it appear over here on my local machine in this path, and then it'll open it up in Notepad++ to edit. So let's do that. As you can see here, a copy got downloaded for editing. It's sitting here in Notepad++. This is the makefile that I use to control the project. So if I simply build the project, it wants to build, actually, that's carryover from a different project. Name of my project here is Octal Dump. This is the default thing it'll do. So what it wants, so if the time date stamp on octaldump.c changes, it'll recompile it. So it does a C compile. It's going to output the executable here, and there's the input source file. So let's go ahead and save this. And now the key here after it's saved is to click back into FileZilla, and it'll pop up and say, hey, the file was changed on the PC side. Do you want to FTP it back down? And it was just FTP'd back down onto the local machine here. So we can see the makefile. My time dates aren't set correctly in BSD, but we can see the time date stamp was at 1300. If we do an ls-l now, we can see that file has been updated. So I should be able at this point to just do a make. Make will say it's up to date, which it isn't. I'm going to go ahead and remove OD, which is the executable, and I'm going to make again to force it to actually make it. It's compiling it, and we've created a new executable. Let's go ahead and edit the C source file, since that's really what I'm interested in doing here. Right click, view edit, it got downloaded, and here it is open in the editor in Notepad on my PC. And again, you can see I've got color syntax highlighting, comments are in green, etc. And what I'm doing is working on converting this from only being able to take an input file to actually being able to read from the console as well. It's a little more Unix friendly that way. So the first thing here is these lines just aren't necessary anymore. These lines are just going to go away. The closing brace for that needs to go away. This statement right here is going to get cut out. Again, this was structured to only deal with an input file. So if argc is greater than 1, it tried to pass I tried to pass a file name on the command line as the first parameter. So it's going to attempt to open that file. We're going to do here if not fptr. I want to execute this bit of code here and exit the program. So it basically says if there's a command line parameter that was passed in, I'm going to attempt to open whatever that was passed in as a file. This file pointer will get set to a null if it can't open it. So if not null is true, the file wasn't able to be opened, and it's going to give us an error message on standard error, and it's going to exit. So that's the first thing we really wanted to clean up. We also don't need this code here anymore. Let's go ahead and wipe that out, and I believe that comes down to this brace. And now I'm going to take this large block of code here, which is that main loop, and I'm going to control tab. Oops, not control tab, shift tab to indent it. And the indentation isn't perfect here. I got a lot of cleanup to do on this. We'll go ahead and indent this as well. Yeah, let's just continue to clean up here. Shift indent, tab. Well, that's not working the way I would like it to. And tab to get my indentation the same. If argc is greater than 1, and you can see here working in Notepad++ is actually kind of nice because I'm able to do these things at the keyboard. Let's get the indentation on him cleaned up so it's consistent. So we've got our main entry point here. It gets past argc, which is the counter arguments in the command line, and argv. If there's greater than 1 command line argument, we know there was a file name passed. The first entry in argv is always a dump of the system environment. So it's going to have paths and stuff in it. So there's always going to be at least one thing coming in here. If I passed a file name, that would be actually an argv sub 2. Or an argv sub 1 actually. 0 is the environment, 1 is the passed-in variable. We attempt to open the file. If we can't open the file, we fail. I think this is clean enough to be able to try to compile it. I saved it up here. This should wake up and say, do you want to FTP it back down? It's been FTP'd back down. Let's go ahead and make it and see if it'll compile or if I've created an error someplace in the file. So it did compile. If you look at my make file, I tend to build tests into the make file. So test 1 will run the local compiled program and pass it the C source code to be converted to an octal dump. So let's try that. Make test 1. And it looks like that's working. So we can see it dumped the file here. It's dumped an octal. We have an octal address here. So my dumped octal worked. So what I'm actually working on doing in the source code here, however, is allowing it to take input from the standard input from the console. And that way I could pipe content to it to do chaining with the pipe commands at the Unix command line. So while C is not equal to end of file, so C is the character we're going to read in. So something you'll notice here is I set C to a space by default. It's initialized to a space, and that way it'll enter this loop. This could probably be done with a do while and the while at the bottom, but I didn't do that. Buff depth is the depth of these buffers. In this case, it's set to 8, and that's because I want to output 8 octal values at a time, and then the 8 ASCII equivalents at a time as well. So this code can be converted to do hex as well. So we're going to go through and we're going to read in characters in this case. So if argc is greater than 1, we know we opened up a file, so we're going to get a character from the file, else we're going to get it from the console input from standard in. If we're not at the end of the file, we assign that character to a position in buffer, and this 1 here says we had a legitimate character there. Else we come down here because we've actually hit end of file early. So in this case, the file happened to match exactly. It looks like the 8 bytes here. If the end of file was actually here, I wouldn't want those displayed. So that's what this flag field takes care of. So we actually found a legitimate file that wasn't in a file. We stored it in the buffer. We flagged that it was legitimate, else we just fill it with a null. It doesn't really matter, and we say it wasn't a legitimate character. We know in this case that if flag position 0 has a 1, we found at least 1 byte to output. We have a printf here that creates the octal address portion of this, which is this string right here. This is 10 characters wide, 3, 6, 9, and 10. We're going to output a long octal value, so the L is long in octal format. We're going to 0 fill it. It's going to be 10 characters wide. So that's the formatting for this position variable, and that position variable, if we scroll back up to the top and look, is a long. And it's going to write that out to the screen, to the output. We then go in, so we've output now the address. We're not going to walk over that flag and buffer array, again to the buffer depth. And we're going to look at the flag field and say, was there a legitimate character found in this position? If so, we're going to print it out as an octal, 0 filled, 3 characters wide, and whatever that character that was read in was. And that produces each one of these octal output blocks. This walks over all 8. Else, if we'd read to past the end of file, it'll just output a set of spaces, and that way, and hopefully we'll see a demo of this, positions beyond the end of file would just have spaces here. They wouldn't actually have values. If flag sub 0 again has something in it, we know we want to output the spaces here to move the ASCII text out. And then it's a very similar loop. We're going to walk over the buffer again. If the character in the buffer is printable, so space starts at at 20 at 20 hex. So if the value is greater than 20 hex or less than 7F, is 7F actually correct there? Actually, that should be less than 80. Let's take a look. I'm not remembering my ASCII chart here as well as I should. Let's look up an ASCII chart, ASCII chart. And we should find a decent ASCII chart here someplace. And the printable characters start at octal 40, actually, or in hexadecimal 20, and they end really at 126 or at 7E. So my folder's slightly wrong. So if it's greater than 1F, let's actually get here where we can see it. If it's greater than 1F, it starts with a space. And if it's less than, oops, clicking the wrong things here. If it's less than 7F, it's printable. So this is just saying, do we have a printable range of characters here? So we have a printable range of characters. We're going to print the character to the screen. Otherwise, we're going to print out a period. And you may see some periods in here, Like this period right here is a return on the end of a line, or is a new line. Going to print it out. We're going to fall out. We're going to put a return on the end of the line. We're going to move the position of the address out by the depth in 8 bytes. If we open the file, we want to close it. If fptr is not null, we want to close the file. If there was something actually printed across that last line, we just do an extra return. That actually becomes this return right here. I like having that bit of extra space there, although it's debatable whether that's needed or not. Actually, in this case, I want to be friendly to I/O. I'm going to remove that. So the formatting on this file is kind of broken at this point, but that's good enough, hopefully, to get a test of this. So it should tell us we've updated the file. Let's save it. Let's make it, see if it still compiles. I don't know what this delay here is sometimes. The lights are merely blinking away on the PiDP11, but right now it's not. There it is. It takes a second sometimes to get the attention of the console back. That may be normal. If we do make test 1, that will feed the C source code to the make routine, and we should see it dump it out. And we can see here the end of file actually happened right here, and I didn't want to dump garbage out here, and that's what that flag array takes care of, is saying we hit the end of file, so don't output anything here, don't try to output any ASCII characters. So that worked. The next thing to try is, actually, let's create a test 3 in the make file. I'll go back to the make file. We have a test 2. Let's create a test 3. Test 3 colon. And we're going to run the local executable. And I'm just going to leave it there. I'm not going to do anything else. I'm just going to run it. And that should start reading input from the command line. So let's see what that does. Let's save that. Let it upload it. Let's run that test, make test 3. And it should be reading input from the command line. So I'm going to type 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7. And it parsed that. It didn't parse it completely, 7, 8, 9. It missed this 7 here. That's interesting. Oh, that's because it doesn't have enough characters. So now I need to terminate the input. Is it Control Z? Nope. What is it in? I don't remember what the end of file flag is in Unix. Well, I'm just going to abort out here. That's me being stupid. But we can see it actually took console input. So let's now tweak the make file again to create test 4. Oops. And what I'm going to do here is I'm going to cat od.c source, and I'm going to pipe it into od. So what we're in effect doing is we're taking od.c and we're catting it to type it to the screen, but we're going to pass it through od as a filter, and we should get the hex dump of that. This is kind of a convoluted example, but it'll start to test whether that console input's working as expected. So let's do we didn't upload it. Got to remember to upload. Let's do a make test 4. Exit 141 stop. So why? Oh, I know why. Let's go back to the make file. This needs to run the local copy. I actually have a copy up in the bin folder of a previous version, and that version isn't compatible with the changes we're making. Re-upload it. And make test 4. And there we are, catting that file out to standard out, and then the OD program is reading that on its standard in channel and is outputting it to the screen. So that filter is working pretty well. I'm pretty happy with that. The next thing I could do, just because this would be curious, is let's go back to the make file. And I'm going to create a test 5. And I'm going to go a step further here. I'm going to cat od.c. I'm going to pipe it into the OD program, and then I'm going to pipe it. Actually, this won't work at this point. I don't have the other filter program I wanted to play with set up, so ignore that. I've got some other C development to do. Anyhow, I think that really finishes the raw edits for this C program. Now it really becomes cleaning up the source, since the source is rather ugly. Let's take this whole block, clean this up. This isn't the most elegant program. It's meant to function, not to be beautiful. And let's remove the indents completely off of it. And then let's start to clean it up by indenting it out. So we've got this entire block to here. Actually, I did that wrong. Or no, I didn't. I'm just going to work my way through here. I'm using tabs, which I detest in source code, but for now I'm just going to do it with tabs. So I'm going to get indenting here that makes sense to me. You can see one of the cool things here is you can click on the braces and see the closing brace that goes with it. That's another really nice feature of Notepad++, recognizing the C file extension and providing color highlighting. All of this needs to be indented. One more tab. I just hate using tabs, but I want my source to look somewhat clean. So that closes that block out. That's got to line up to the if. Oh, ugly, ugly, ugly. I really don't like this. And always run those two lines. I'm going to shift tab here to remove the indents completely from there. Put them back in. And I think that's at least cleaned up the indenting to some level. Let's save that. Let it upload it again. Let's make it and see if I typed over something or deleted something accidentally. Make test 1. And it seems to be working as expected. So we've got a carriage return at the end of the file. That's what actually no, that's a 12 octal. What character have we got at the end of the file? We have an extra blank line down there, so there's one character beyond that final close brace right here, which is to be expected. It's non-printable, so it printed a period out. Close the input file. We've got all this white space here we don't need. I got a lot of work here to clean up the comments and that kind of stuff. At this point, I'm relatively happy with this. For what it is, it's working as expected. Just gotta let it upload it again. We'll build it one more time. We can actually run it locally ourselves. Octal dump, octaldump.c. If we cat the make file, I believe test2 will dump a very large file. If we do an ls-l root, we'll see a file here named Unix that's a very large file, 157K. And I'm going to go ahead and should be able to now pass that, I can pass that file name to it as Unix, and let's just dump that very large file, and it'll just sit here and do an octal dump to its heart content. So while that runs, I'll recap here again. We've got FileZilla here. We've created a bunch of site manager definitions. I'm actually clicking on the little multi-computer icon there. I've created an entry for my 211 BSD on the IP address that is on my network using an account I created, a user account, and its password. That gets me connected here. So I see my remote site here. There's the a full path on the Unix side, which you should recognize. I was in the home folders, STB, and in my octal dump utility. I determined the temporary path here the system's working on by actually going in here with a file that we had right-clicked, edit, and doing a file save as. And from here you can determine the path. So the path was my login, app data, local temp, that temp folder, and that's the path we have up here just because I wanted to watch the files as they went up and down. So there's that. Notepad++, great editor. Very powerful. I use macros in it all the time. If you ever need a macro editor where you need to apply the same edit, do a ton of lines in a file, create the macro right in the editor, execute the macro, execute it at the end of the file. Really, really nice piece. So I think with that, we've made the changes I wanted to make to this program to allow it to input from either a file or from the standard in. And we'll go from, I'll end this video here and we'll get it posted. I will be putting the source code for these little utilities up on GitHub. There may be details in the description when I post the video, or I'll add those later. All my little utilities will make it up to GitHub. Just so you can download and play to your heart's content. So anyhow, hope this was useful, and we'll talk soon.